Hello and welcome to the next lecture. In this lecture, we will talk about control structures in R. Control structures in R allow you to control the flow of an R program and are very similar to the control structures that you might see in other types of programming languages. The basic constructs are things like if-else for testing logical conditions, the switch statements to test multiple conditions on one object. It's like if-else but are more compact. The for loop for executing a loop for a fixed number of times while executes a loop while a condition is true. Repeat is a construct that allows you to immediately execute an infinite loop. Break allows you to break out of any type of loop, and next skips an iteration of the loop, and return allows you to exit a function. So most of these control structures are not things that you see in interactive sessions and not like while you are typing at the command line in R. These are the kinds of things that typically you would see when you are writing an R program or an R function. It's a little bit more of a structured format. So the first structure is if. So the if combined with else allows you to test logic conditions and let the R program do something depending on whether that condition is true or false. So if the condition is true, then you do something else. That's the typical kind of construct. The else part is optional, so you could just have an if statement to do something if something is true, but you can have the else part if you wanted to do something alternatively. If you want to do more, there can be more than one possible type of condition that you want to check. You can say if and then else, if and then else. Else if, there can be any number of else if conditions in a constant like this, and the else one has to be at the end. So there are a couple of different ways that you can formulate the if else construct in R. It's a little bit different from other languages in case you haven't seen something like this. So the first is pretty standard. If the symbol x is greater than 3, then you set y equal to 10. If it's not greater than 3, then you set y equal to 2. So that's inside the if-else construct. There's an assignment of y to a specific type of value depending on what the value of x is. But however, in R you can do it a different way. You can say y is equal to the entire if-else construct. So if x is greater than 3, 10 or 0 depending on whether that condition is true or not. So this is a valid formulation. Also sometimes it's useful to read this type of writing because it allows you to realize that the entire if-else construct is all about assigning a value to y. So as I said before, the else clause is not really necessary. You can always test the condition and do something and then do nothing if that condition happens to be false. So you can just test multiple conditions in a row if you want. Next is the switch statement in R. A switch statement is used to execute different blocks of code based on the value of a single variable. It is similar to an if-else statement, but it is more concise and easier to read when there are multiple conditions to check. The basic syntax of a switch statement in R is switch function with expression and cases and then the default value. The expression is the variable or expression whose value is being tested, while case 1, case 2, etc. are the possible values that the expression can take, and the default case is optional and is executed if none of the previous cases are true. Here is an example of how to use switch statements in R. In this example, the value of x is 3, so the third case is executed and the output is the value of x is 3. If the value of x was not one of the defined cases, then the default case would have been executed instead. You should note that in R, the values used in the cases must be characters or numbers, and they must be defined in quotes or without quotes respectively. Additionally, the switch statement evaluates only the first argument and returns the result of the matched expression, so it should not be used to generate side effects or multiple statements. So the next is a for loop. So this is probably the most common type of loop operator that you are going to use in R. The basic idea is that you have a loop index which is typically called I, but if you have many loops you might say j, k, l, etc. And a loop index, it's going to cover a sequence of numbers typically in integers. So for example, here I've got a for loop and it's looping over the numbers 1 through 10. So I've created the sequence with colon operator 1 through 10, and this for loop is not doing anything particularly interesting. It's just printing out the numbers, so printing out I at each iteration. After the loop is finished, it continues on to the next block of code. So there's different ways to use a for loop, and the R is pretty flexible in how you can kind of index the different type of R objects. So here I've created a vector, a character vector with the letters A, B, C, D in it, and all these for loops are equivalent. So for example, in the first one here, I have an indexed I that I sequenced through 1 through 4. I created an integer sequence. Then each time I print the ith element of X. So here this loop just prints out A, B, C, D. Another thing I could do is use the seek along function. So what it does is it takes a vector as an input and it creates an integer sequence that's equal to the length of that vector. So this is a vector of length 4. So it's going to create an integer sequence 1 through 4. It's exactly the same as the previous sequence where I've got the sequence 1 through 4. However, here I generate the sequence based on the length of the variable X. So now my index serial I is going through this sequence. It's printing out the I filament of X, and exactly the same behavior occurs. I print out A, B, C and D. The third example here, I've got a different index variable. I'm calling it letter, and the index variable is actually going to be taking values from the vector itself. So there's no reason why the index variable has to be an integer. It can take elements from any arbitrary vector. So now the for loop is going through this vector of letters A, B, C, D, and it's just going to print out the letter itself. So now I am printing out the index variable, which happens to be equal to the letters in the vector. And so these three for loops are exactly the same so far. The last version here is the same as the first one, except I haven't included the curly braces. And so if the for loop only has a single expression in its body, you can omit the curly braces and put everything on one line, which may be useful sometimes because it's a little bit more compact, but it's not particularly my style. For loops, I generally like to put the curly braces in regardless of how many elements are in the body. For loops can be nested, so you can have a for loop inside of a for loop. So the common thing, for example, is with the matrix that has 2 dimensions, and then you might want to loop over the rows and then loop over the columns. So here the outer loop with the I index is looping over the rows, and I'm using a function that's called seqlen. So the idea is that it takes an integer, which in this case happens to be the number of rows in X, and then it creates an integer sequence out of that. So this particular matrix has 2 rows, so it's going to create the sequence of 1 to 2. Similarly, the nested loop with the J index is using the number of columns to create a sequence. So this matrix has 3 columns, and so the seqlen function is going to create an integer sequence 1 through 3. So this doubling nested for loop is basically printing out all the elements of the matrix. So one thing to be careful with nested for loops is that it's going beyond 2 to 3 levels. While it's theoretically okay in R, it makes reading the code a little bit difficult to do. And so if you are reading code that has 3 or 4 nested for loops, it gets difficult to understand what's going on. Sometimes that's the logical thing to do, but many a times there's ways to get around that. For example, by using functions. This is all for this lecture. See you in the next lecture, where we will continue talking about other control structures in R. Till then, ciao.